Again, I'd like to welcome everyone to this virtual open week. And this is our last session for this almost a week long activity, which happens only once a year at EIT. And in the session, we will be talking about the mechanical engineering at EIT, and you'll be hearing our lecturers' insights. And these will be insights from Dr. Milind. He is our course coordinator and lecturer, and Dr. Arti, she is our RPL coordinator and lecturer. We also have Dr. Aravind, our vet program leader and lecturer. So I would now give this discussion to our lecturers to start the session. Thank you so much.
Thank you very much, Lisa, and welcome everyone to this Lecturers Insights session, which is focusing on mechanical engineering at EIT. So we will briefly introduce ourselves, and then myself and Dr. Aravin, we will try to cover mechanical engineering overview, and then we will hand it over to Dr. Milind to cover pathways, courses, and remote labs, where I might jump in if time permits. And of course, we will ensure that we have enough time for questions and answers. All right, so moving on with my introduction, my name is Aarti Sidpura. I am RPL coordinator as well as lecturer here at EIT in mechanical engineering. I've been in academia since 2003. I've done my PhD in mechanical engineering, and I'm responsible here at EIT for delivering various bachelor's, master's, and doctorate of engineering units. My research interests, as you can see, they are basically in condition monitoring, diagnosis and prognosis of tool life, as well as smart manufacturing. All right, so that's about me. I would like to invite Dr. Aravin to introduce himself.
Hello, everyone. My name is Arvind Armugam. All right. Again, I've been in academia almost quite 19, 20 years now, right? I graduated with my bachelor's in mechanical engineering and PhD in engineering from the Nottingham Trent University, United Kingdom. Before moving in to Perth, Australia, now just like Milind and Arti, we are based in Perth. But prior to that, I originally came from Kuala Lumpur, Malaysia. So I have a huge amount of my academic experiences have been in the universities in Malaysia before coming to Perth, and joined EIT in 2019. So been with EIT for quite some time now. Recently, I took up the program leader position as the VET program leader for Advanced Diploma in Mechanical Engineering. Thank you. So I can just now pass it to Milind now.
Thank you, Arvind. And hello and welcome, everyone. You can see this slide here. So I'm Dr. Milind, and I'm the course coordinator and lecturer in mechanical engineering. So as you can see, I have a few years of experience in academia and industry all around the world. I did my PhD in mechanical engineering from a local university here in Perth, and received a few awards and published quite a few research articles. For past 5 years, I'm serving as a course coordinator in mechanical engineering. So as a course coordinator, I actually look after entire higher education portfolio in mechanical engineering. So I actually make sure the delivery and the content of bachelor's and master's level mechanical engineering courses is highest, and you can provide, you can have the industry focused courses, high quality courses, which is quite useful, and you can hit the ground running when you look for employment. So I'm quite excited to welcome you all, guys. So over back to Aarti. Thank you.
Thank you, Milind. All right, so moving on, I will cover mechanical engineering overview, and I will try to elaborate a bit further on what sits under this big umbrella of mechanical engineering. And then I'll pass it on to Dr. Aravin, who would cover potential jobs as well as some trending as well as future topics in mechanical engineering. All right, so let's get started with mechanical engineering overview. What is mechanical engineering? So mechanical engineering, you can say it's a branch of engineering that focuses on design, analysis, manufacturing, as well as maintenance of mechanical systems. You can say any mechanical system, cradle to grave, the whole journey takes place with the help of mechanical engineers. They support that journey at each and every phase. Now, it's quite a diverse field, as you can see. It combines so many different principles of physics, maths, material science, other engineering, where it relates with creating, optimizing, and operating a wide range of mechanical systems and devices. So as you can see, the importance, mechanical engineers, they play a very crucial role in various industries. That includes, as you can see, quite a few examples here: earth-moving machines, automobiles, aerospace, space engineering, all those things. Mechanical engineers are supporting all those things. All right, so moving on, elaborating a bit further. So industry interest, and there are infinite possibilities in terms of mechanical engineering. I would say it's really hard for me to think about something or some area which is not supported by mechanical engineering at any stage where it goes through the design process. You will need a mechanical engineer whenever you're designing something. So the field is that broad and that important, I would say. So just to give a bit more idea, mechanical engineers, they create manufacturing facilities which would have large machines, a lot of automatic machines as well. And those machines serve so many other industries as well. Mechanical engineers are also responsible for coming up with transportation systems, automobile industry. That is also part of mechanical engineering. And in addition to that, we also develop specialized tools and equipment, both for personal use as well as so many other important fields, as I've just mentioned, like space, aerospace, oil and gas, mining, healthcare, and whatnot. Right, so let's move on and have a look at what sits under the big umbrella of mechanical engineering. So there are quite a few different sub-branches coming out of the mother branch, that is mechanical engineering. You can see the list over here. I wouldn't read the list, but instead what I'll do, I'll just go through each and every field one by one through the slides. All right, so first one is computer-aided design. This is the most integral part of mechanical engineering, and I'm really passionate about this. I can keep going on, and I can keep talking for so many hours. But just to put it in a nutshell, mechanical engineers, they create detailed plans and blueprints for any mechanical system or any mechanical product. So it involves selecting appropriate materials, specifying dimensions, ensuring that systems functionality and safety is there as well, and it will serve the purpose. So for computer-aided design, they use special softwares and also the simulation that will help them evaluate those products in terms of their stress and strain analysis and whether they will sustain the forces that they will come across while being in the operation. So also it will ensure that those systems will meet the performance requirement standards, regulatory requirements, or those kind of things are included in the design part. Manufacturing, now manufacturing and mechanical engineering, I would say they are synonym to each other. Manufacturing engineering is very integral part of mechanical engineering. So mechanical engineering encompasses this whole branch of manufacturing. Whenever a machine, any machine is involved in terms of manufacturing any part, carrying out any operation related to manufacturing, it's all sits under mechanical engineering. So mechanical engineers, they oversee entire production process with manufacturers, and they also ensure that products, they are built correctly and efficiently. Coming to automobile engineering, so automotives, they work on design part, not just design. It has a lot to do with material selection. It has a lot to do with thermal and thermodynamics principles as well. So, and also aerodynamics, because we want our cars and automobiles to be quite efficient aerodynamically as well, so that we get that fuel efficiency. So that is also part of mechanical engineering that uses a lot of basic principles from mechanical engineering branch. Air conditioning and HVAC, so heating, ventilation, and air conditioning. So this particular branch of mechanical engineering, it ensures that there is a controlled indoor environment, That also includes right amount of temperature. In winter, you want to feel warm. In summer, you want to feel cold. So how to achieve that? That's part of this branch of mechanical engineering, HVAC, and also the air quality that you are getting. Next is materials engineering. So this particular branch of mechanical engineering takes into account various different properties of materials, and they analyze them for the stress, strain, and other required properties for that given application. So knowledge in this particular area is super important for designing structures as well as mechanical components. You need certain component to serve or function in certain environment. There are certain constraints that you need to fulfill through the selection of materials. Next is power plant engineering, or in general energy engineering. Now you might ask that energy and power is all about electrical engineering, but at the back end it's a lot of mechanical engineering. So mechanical engineers who are working in this energy sector, they are involved in designing and improving energy generation systems. Also energy generation systems include power plants as well as the sort of steam turbines, gas turbines, and whatnot. So all those back-end components, they are pretty much mechanical. Nowadays, renewables are also coming into the picture, so that is also part of energy engineering. Next is mechatronics and robotics engineering. So mechatronics actually integrates mechanical engineering with electronics, as the name suggests, and as you can see. There is also amalgamation of computer science and control engineering into that field. And mechatronics is mainly used to design intelligent systems, robotics, automation, etc. So that's where it's a combination of mechanical and electronic. Next is agricultural engineering. So you might ask, agriculture has a lot to do with farming and those sort of processes. But if you think about the equipment which are being used for that, and also the automation which is needed in countries like Australia, where we have huge farms and not enough manpower available, you will see clearly that there is a huge role that mechanical engineers play in terms of designing those equipment and maintaining the efficiency of those equipment. Next is mining engineering. So mining engineering, while it's quite distinct when it comes to the focus, it has the focus on mining and extraction of mineral and resources. It does share fundamental principles with mechanical engineering. Now, mining covers design and operation of mechanical side, and that covers the drilling rigs, crushers, conveyors, other material handling equipment. These are all part of mechanical branch where it comes to designing and operation of this equipment. Then we have oil and gas. So again, oil and gas also has a quite different focus as compared to mechanical engineering. But again, there are quite a few different mechanical components involved in oil and gas. So you can say the whole rig, also the pipelines. A lot of pumps are also being used. So these are all parts of mechanical engineering, and that's where mechanical engineers play a huge role in terms of oil and gas industries. We have marine engineering as well. So marine engineers, they are responsible for designing, analyzing, and maintaining mechanical systems on ships. That includes engine, propulsion system, and auxiliary machinery. Now, marine engineering is quite interesting because, again, a lot of principles from mechanical engineering goes into designing those vessels. Thermodynamics, fluid mechanics, aerodynamics, all so many different principles are combined when you have to design a super efficient vessel. And I think this one would be the last one, but aerospace engineering. So again, now, as I have been explaining throughout all these slides, you might think about this as well. Aerospace engineering, it focuses on design, development, and testing of aircraft, spacecraft, and other related systems. And again, propulsion engineering, thermodynamics, thermal engineering, fluid, all those things will play a super important role in aerospace engineering as well. And not to forget about the material selection, that we are always trying to achieve the lightest aircraft with highest weight carrying capacity as well as greatest efficiency. So I hope I have made it clear to you where exactly all those things sit under the big umbrella of mechanical engineering. I'll pass it on to Dr. Aravind. Thank you.
Thanks, Dr. Arti. Hello, everyone. I'm just going to summarize what Dr. Arti have actually said in here. So potentially one who have actually completed a degree in mechanical engineering, with potential will end up in one of these industries or in one of these job descriptions, right? So nowadays, as a mechanical engineer, you might be doing some work related to design, related to manufacturing, related to buildings, and obviously, if you might end up also taking engineering courses like industrial engineering, mining, oil and gas. But end of the day, in all these engineerings, they are actually what we call as engineering which are part of a particular field, right? So in a mining engineering, you might be a mechanical engineer. You can also be working with guys who are electrical engineers, civil engineers, and so on. So engineering has actually become quite well knitted at the moment. And as a mechanical engineer, you might end up working in the field of mining with engineers from other branches of engineering. Anyway, saying that, let's look into, as a mechanical engineer, what are the areas that are coming up at the moment? What are the trending areas here? Well, Dr. Arti have actually talked about computer-aided design, so I'm not going to go too much into that. So yes, computer-aided design is simply one of the important part of being a mechanical engineer. All mechanical engineers need to know computer-aided design to an extent. You should be able to, in a way, translate your ideas into physical digitized drawings that can be later on be used by manufacturers in the computer-aided manufacturing. So CAD, CAM, both of these are, in fact, they are very much a combined area. So we call that in together as CAD-CAM, computer-aided design, computer-aided manufacturing, where in both of these, we are using computer softwares in order to design as well as in order to manufacture parts that are more accurate, which are more precise, and have got the right amount of structures and stuff like that. Now, under the same computer-aided manufacturing, we also got another field that is kind of coming up quite vastly, rapidly, I would say, that is the additive manufacturing, 3D printing, right? The field of 3D printing involves building up products by creating layers of materials. 3D printing used to be something that was well, it was quite what we say is only once in a while you come across this. But nowadays 3D printing is quite common, that you can even buy a 3D printer and keep it in your room and start building products. So it's already becoming so widely available. Everyone pretty much knows 3D printing, all right? So unlike about 10, 15 years ago, 3D printing was kind of a niche area. So but it's coming up. A lot of room for things, room for advancement in this. So together with that, we have also got a lot of advanced manufacturing. For example, laser cutting, water jet machining. Now, these are just two examples of precision manufacturing. Okay? Because when it comes to laser, the laser has to be precisely controlled. This is where it's obviously part of computer-aided manufacturing. By using computers, we control the laser intensity, we control the pressure of the water. Now, all of this kind of comes together under computer-aided manufacturing. Advanced manufacturing is another area, a trending area in mechanical engineering, where you will come across. We are actually coming into developing a lot of advanced processes nowadays because of the way materials are coming up. Materials are also rapidly building up because we've got a lot of new composite materials. We've got smart materials. So a lot of things happening in materials. So as a mechanical engineer, you'll obviously find there's a lot of things that you need to know about materials. Yeah. Computer-aided computational fluid dynamics, final element analysis. Now, both of these are simply using computers in order to do analysis. The only difference is FEA uses what we call as this two-dimensional elements in order to probably analyze a structure, the stress, force in the structure. Right? Computational fluid dynamics looks into the flow of fluid, liquid, gas, and it uses slightly a different mathematics behind it, right? So yeah, they both involve mathematics, but don't worry too much about that. You won't see mathematics. You won't see all these partial differential equations and so on, even though that's how it's made. That's how the software works, but that's at the back end. You'll be obviously be seeing nice, colorful visuals, but it's obviously a field of study which will be quite interesting if you go into mechanical engineering. And obviously finishing this off with aerospace and dynamics, aerodynamics. Yeah, as I was saying, 3D printing, and 3D printing first started. The material that was used was most of the time plastics, polymers. But now we have got 3D printing, which uses metals, right? So we got this, the design can be created using a CAD software, like SolidWorks and AutoCAD or whatever, and that will be later on transferred to this machine where you got a laser beam which will selectively melt the material layer by layer, all right? And then once it's actually built the material will be removed. Obviously, it won't be in its final form. There's a bit of additional processes needs to be done. That's how manufacturing is. So you will take the material off, put it into a heat treatment process to give it some important material characteristics, all right? And then after that, we'll end up with the final product. Now, the thing with 3D printing is, with the 3D printing, especially 3D printing metal products, we have actually taken away the cumbersome process of machining intricate shapes. Because machining intricate shapes using milling machines and drillings and all these typical manual machining, okay, used to be quite hard. But nowadays, we can easily build them. And most of the time, these are being used as prototypes before the final product comes out. So 3D printing, a very important area to look into. After 3D printing, we've also got, now we are obviously looking into 4D printing. Okay, where's this 4-dimensional came from? Okay, the 3-dimension that we saw a while ago, the 3-dimensional product was very much a rigid product, 3D, right? All the 3D products. Nowadays, we are looking into 4D printing, where the 4th dimension involves the ability of this material to deform or change shape due to some sort of external stimulus. For example, we've got these hydrogels and we've got these piezoelectric materials, which may react to changes in temperature, changes in pressure. So material like this could be developed in 3D, and then the 4th D is to change the shape in order to create designs, in order to create some sort of application. 4D printing is widely used, is coming up quite fast. We can use that for repairing pipes, right? In the case if a pipe needs to be repaired, we can easily send materials like this, which can deform itself in order to close the gap. So a very important, interesting area to look into. Well, computational fluid dynamics, as I said, that's an area where we widely look into whenever we talk about flow. So whenever either is looking into designing aerodynamic aircraft shapes or automotive chassis, or analyzing flow in valves, in pipes, even to the extent of analyzing flow in our heart, CFD is being used. CFD is obviously an area that has been around for quite some time now, and it's got a lot of potential. You can be an engineer who literally involved in just doing CFD throughout your whole entire work life. Yeah. And electrical vehicles. Now we've got EVs coming up. A lot of electrical vehicles are coming up, but not to worry. Okay, just because we got electrical vehicles doesn't mean mechanical engineers are going to lose their job. Okay, because electrical vehicles, the whole entire thing about electrical vehicles is the transmission part of the vehicle is going to be electricity. But you still need to design you need to still manufacture the car. So you need to still look into the powertrains, the gear systems. You need to still look into the materials. Obviously, materials engineering is part of mechanical engineering. All right. So we need to we're looking into materials like aluminum and composite in order to make this vehicles lighter. All right. So they can be able to fit with the required batteries and so on. So electrical vehicles are obviously coming up, but that they are obviously not a threat to mechanical engineers. We still have job in manufacturing, in automotive. What else? And nanotechnology is another area. So engineering is obviously going nano, no more micro. We are going into nano sizes. We are looking into materials, changes in materials property using nanoparticles. We are already building robots that are as small as the size of a mosquito, of an insect. Okay, all of these are going into nano level. So we have got a lot of design in the nano scale. So even nanotechnology involves a mechanical engineer. And biomechatronics, the other one. Mechatronics was obviously there as part of mechanical engineering, but whenever you're using a mechatronics product, incorporating it into biology as a prosthetic arm and prosthetic legs and so on, that's where the mechanical engineers will come. And finishing off my presentation would be with the introduction of Industry 4.0. Now, Industry 4.0 is in fact going to change into Industry 5.0 in the next 3 or 4 years, because we are already talking about Industry 5.0. But end of the day, what is Industry 4.0? It's the fourth industrial revolution, right? So the way industrial revolution have actually progressed in the past. Our first industrial revolution started with the whole concept of the use of steam power. All right, this is in the 18th century. Then we went into Industry 2.0, the second industrial revolution, where we were using where mass assembly, mass production was talked about. Then Industry 3.0 is very much where we are in the moment. In fact, we did this 3.0 to 4.0, where we looked into the use of computers in manufacturing. Industry 3.0 going into 4.0 uses connectivity, the whole concept of there's 4 things that we are looking into in 4.0. Connectivity, data connectivity, the use of internets and so on. Analytical, intelligence, that is AI, artificial intelligence. Human-machine interface, and as well as advanced manufacturing. So if you notice, advanced manufacturing, human-machine interface, as well as AI, these are obviously part of mechanical engineering. So when you combine all of that, you've got Industry 4.0, right? Industry 5.0 looks into kind of merging all of this. So we're looking into manufacturing in a more different way, rather than how we look to manufacturing in the traditional manner, right? So we are looking into integrating information, either in manufacturing, design, procurement, logistics, everything being put together. So all this comes together in order to create a well-efficient manufacturing. So 4.0 is what we are looking into. But we are already going into 5.0 to let you guys know. As part of 4.0, there are some other aspects of 4.0 that is being that requires a lot of improvement, and obviously being widely talked about and researched. That is the digital twin. So we can actually develop simulations that kind of replicate the actual system. So rather than doing experimentation on actual system, we can actually do a simulation in this digital twin and work out areas for improvement, work out areas where there could be some sort of problems. So digital twin, this is obviously part of Industry 4.0, right? And apart from that, as I was saying, it's not only about the engineering part, it's also looking into the procurement part, the logistics part. So we've got the data management, how data can be disseminated, how data can be processed, how data can be stored. So all of this comes under this huge umbrella of Industry 4.0. And obviously, finishing off my presentation today is the product life cycle management, another area that comes under manufacturing. Okay, but as I said, now manufacturing has shifted to a slightly different paradigm. So we are looking into internet automation and so on. Now, just to finish my thing, the Industry 5.0 that we are pretty much looking in somewhere in 2026, 2027, in the near future, we are looking into the integration of robotics. So mechatronics, robotics is obviously the area that a lot of people are going to be ending up doing if the days that you guys are working probably in the next 5 years, 6 years. Don't be surprised that you'll be working. Your co-worker might simply be a robot, right? Even though that's how things are now, but it will be more extreme at that time. Fine. With that, I've finished my part of the presentation to look into mechanical engineering's trending topics. So with that, now I'll pass to Dr. Milan to talk about the course in EIT. Dr. Milan?
Thank you, Dr. Arvind. So obviously, I'm really excited to welcome you all again to this session, and I'm really thankful to Dr. Aarti and Dr. Arvind for giving very fabulous introduction and overview of the entire mechanical engineering branch and variety of sub-disciplines of mechanical engineering. And I'm pretty sure all of the attendees are now quite curious and quite excited to learn about the different courses EIT offers, which can probably help them upgrade or join mechanical engineering discipline, because mechanical engineering is the evergreen discipline of engineering. If you become a mechanical engineer, you are employable almost everywhere in the world. That's what I believe. So let's dig deeper into the actual courses. So in terms of EIT offerings, we actually offer the full range. So even if you want to start up with a small advanced diploma type of courses, advanced diploma in mechanical engineering, you can actually start with that if you have some trade background. Yeah. If you have completed your year 12 in the high school, you could either join undergraduate certificate, which followed up by Bachelor of Science in Mechanical Engineering. And then a higher level would be graduate certificate, which is more like a starting of a postgraduate certificate. Then we offer Master of Engineering in Mechanical, or you could complete up with a graduate diploma in Master of Engineering. And we also offer Doctorate of Engineering in Mechanical. So that's fabulous. The all throughout, starting from advanced diploma to doctorate, almost all the AQF levels from level 6 up are covered here. So going to the next one, the very first category we have is called Professional Certificate of Competency courses. Now, for these courses, normally entry requirements are almost nothing. Anyone can actually join these courses with some kind of engineering background. They would be eligible. And these professional certificate courses are normally more used by people working in the industry or someone keen to learn about mechanical engineering. And it's just 3 months course. And you can see the range of courses we offer in this 3 months course: mechanical, chemical, gas turbine, HVAC, hydraulics, onshore offshore pipeline systems, and practical mechanical sealing, and process plant and piping. So range of short courses to get you going. If you are already working in industry, you might be wanting to know a bit more in a specific sub-discipline of this mechanical engineering courses. So that's professional certificate. And the next one are called advanced diploma courses. So advanced diplomas are basically, if you have some trade background, you would be eligible to get into this. And we have two: Advanced Diploma of Mechanical Engineering Technology, and we have Advanced Diploma of Plant Engineering. These courses, each of these courses is typically 18 months. Yep, 1.5 year. After you start to finish, it would take 1.5 years. So just give you a taster of what typically involves in mechanical engineering advanced diploma. So in over 18 months, you would be studying around 21 modules. So these are all bite-sized modules. As you can see, each module is roughly around 2 to 4 weeks, not too long. And it would give you, more like an overview and detailed knowledge about each of these sub area of mechanical engineering over the course of 18 months. So as here you can see, upcoming intake for advanced diploma is mentioned right here. So if you are looking to join it, it's time to actually start enrolling for that one. All right, feel free to put your questions or curiosity in the chat box. If you have any question related to this particular advanced diploma or professional cert or bachelor's, feel free to put your question in the chat while I'm talking. And the next one we have is the higher education programs, where I am actually the course coordinator and I look after the entire higher education portfolio, including undergraduate and postgraduate courses. So these two courses, undergraduate certificate in mechanical and engineering foundations, these are actually 1 semester long courses, 6 months courses. But if you want to do the full bachelor's, we offer Bachelor of Science in Mechanical Engineering online, and we offer the exact same course on campus as well. So online or on campus, both of them would take around 3 years in a full-time mode, and obviously much more than in part-time mode. So you could take up to 8 years, 7 to 8 years to complete this in a part-time mode. But if you enroll as a full-time, it would just take 3 years. Okay, and then we have postgraduate courses. So if you want to do just 1 semester or 1 year of the master's, then it is called, 1 semester is called graduate certificate in mechanical engineering, which would take 6 months. If you want to just do 1 year of postgraduate, which is called graduate diploma, it would take 1 year. But if you want to do full 2 years, full-time master's degree in mechanical engineering, you could join Master of Engineering Mechanical either online or on campus. Yep, online means you can do this course from anywhere in the world, or all you need is the right attitude to learn new things, a laptop, and a good Wi-Fi or internet connection. And if you want to join on campus, I would talk to you about that in a moment. Where exactly do we offer on campus in the world? Okay, so these are the bachelor's and master's degree level courses. And finally, the highest qualification we offer is Doctorate of Engineering or Doctor of Engineering, which started around 3 years ago and is hugely popular among people working in the industry, and they want to do really, industry-focused research. They would enroll into this, and it's a 3-year full-time course, or maybe a bit more if you are doing part-time. This course is also offered online or on campus. It means there is a possibility to come on shore in Australia, or you could do it online. So here you can see some intake dates for online and on campus right here, and bit of description for you to read. But Doctor of Engineering in any discipline we actually offer, but in mechanical engineering, all of these sub-disciplines Dr. Aarthi and Aravind mentioned, it is possible to pursue your research with a Doctor of Engineering. So you would be called a doctor if you finish this qualification, basically. All right, moving forward now, some of you might be interested in joining EIT's on-campus program. So you want to do the bachelor's, you want to do a master's, but you want to come in Australia and do an on-campus course. So we offer this Bachelor of Science in a variety of disciplines, but Bachelor of Science in Mechanical Engineering is offered only in Perth, in Australia. So that is the western part of Australia, Western Australia. That's where the Perth city is. That's where I belong to. I live in, and you would be, studying this with you would be, studying this with me. And then we have a Master of Engineering in Mechanical as well, but that course is offered at 2 campus locations. One is Perth, one is Melbourne. In both of them are in Australia, obviously, and those are your choices. So moving forward, I can see some questions coming up, so that's pretty good. What I could do, we would actually answer your questions bit at the end, if you don't mind. So you might be wondering, EITs are offering online and on-campus programs. So how about the accreditations? So all of these EITs courses are fully accredited by TEXA, which is Tertiary Education and Qualification Standards Authority, which is the key body in Australia approving all of these courses. So these courses are equivalent to any course offered by any university in Australia. So it's quite equivalent. So here you can see, two master's degree and bachelor's degrees, they are fully accredited by Engineers Australia as well, but they are all fully approved by TEXA as well. Just Bachelor of Science in Mechanical Engineering is fully accredited by both TEXA and Engineers Australia. And Master of Engineering in Mechanical is fully approved by TEXA, but it is provisionally accredited by Engineers Australia. Just to let you know, Master of Engineering in Mechanical is yet to receive full accreditation from Engineers Australia, but it's happening very, very soon. So that's that. And moving forward, I would like to talk about course delivery. So how do you do, like whether you join online mechanical engineering course or on campus? Doesn't matter which mode you join, the experience is excellent in both the modes, because EIT is pioneer in online learning for last 10 years. Not due to COVID, even before, well before COVID, we've been running these courses fully online and also on campus in a very advanced way. So we run the courses synchronous, where some of the sessions are live, like you're listening to me right now, or some sessions or lectures are recorded, and it's actually a mix of both. And we have a global pool of lecturers. So you have 300 plus lecturers streaming into your classroom, teaching you, and these people are experts in their field. They are not just some people with a degree and they know how to read from a book. These are real experts working in the industry and have a very strong background teaching you industry focused courses or subjects. And we have global pool of students. We have more than 1400 students, and I think more than 150 countries now reach who are actually studying these courses. I'll be talking about virtual and remote labs as well very, very soon. So we have very high quality, realistic virtual and remote labs, which you can access 24/7. Doesn't matter where you are. And in terms of online libraries, obviously we rely heavily on online libraries. You can access journals and lots of articles and some of the books also in our online library as well. All right, moving forward. So I was talking about we have 300 plus lecturers. So you might be wondering where these lecturers are. So we are not limited by any geographical barrier. So even if you are studying in Perth or Melbourne, or even you are studying the course in online, you may, be having lecturers streaming in from USA or Canada or Brazil or India or Saudi Arabia, Portugal, UK, Spain, South Africa, or New Zealand. So we have lecturers all around the world, because we like to source the best of the best people to teach you the subjects which you are enrolled into, right? So that's there. And in terms of course delivery, if you are attending lectures or tutorials, we use Blackboard Collaborate as our main tool or room in which you'll be live with your lecturers. Right now we are in Blackboard Collaborate, as you can see, and we also use Moodle and Trust RTO for all of these course materials and so these are very, very streamlined platforms on which your experience of education would be very, very smooth. Yeah, and next bit is mechanical engineering labs. So people usually ask, you run exactly the same bachelor's and master's in fully online mode and also on campus. How do you do your labs? So guys, we actually have remote and virtual labs. So I'm going to talk about that a bit. So we have the remote and virtual labs all over the world. Some of these remote and virtual labs are having servers in Western Australia, South Africa, United Kingdom, and so on. So these servers actually are all connected. So it doesn't matter you're doing on campus or online, you can remotely access these labs from anywhere in the world and 24/7. So some of these examples are given here in terms of photos. I can't reveal everything, but some of these, experimental setup are there in the laboratory, and you can remotely operate the sensors and some of these rigs by just using your laptop and a good internet connection. So you can remotely log into this laboratory setup, and there is a web camera fitted there. You can see how this equipment are operating, and you can take measurements and you can do your lab. And in case, what happens in a traditional lab, in case if you miss the lab because you were sick, you wouldn't get to do that lab again, right? But with EIT, these labs are accessible 24/7, and you can do unlimited attempts. So you want to do one lab for 5 times or 15 times, there you go, you can do it. You can actually even log into that lab 3 a.m. in the morning. So that's what happens in our labs here in Australia. Students are logging in and doing their experiments middle of the night. So our lab is always buzzing with activities because we have students from all around the world. And so that's the remote lab. And we also have quite a few expensive software which are used in mechanical engineering, like in AutoCAD, Automation Studio, Python, MATLAB, SolidWorks, ANSYS, Festo, FluidSim, Gesture, Simtronics. All of these softwares are quite expensive. So students would normally struggle. They have to book a lab in a traditional university setup, right? Or if they're doing online, they can't really access any of the software, and they can't purchase them because they're quite expensive software. So what we did at EIT, we actually installed all of these softwares in our international servers in WA, in United Kingdom and South Africa. These servers you can remotely join from anywhere in the world using just your laptop, and you can access all of these softwares remotely, and you can do all the work, and you don't have to wait for booking, going into a room in the daytime during work hours. So these softwares are available 365 days, 24/7, and that's the beauty of EIT's software and hardware labs. I can give you some examples. For example, in CAD/CAM, you would be doing CAD/CAM in which you would be, computer-aided design and manufacturing. It means you would be designing and drafting quite a few mechanical components which could be used in vehicles or machines or spacecraft. All of these could be done here. A finite element method is very, very powerful tool to analyze stress and strain and a variety of elongation and strength analysis, and that's possible using ANSYS. ANSYS CFD or Fluent is also quite useful in analyzing flows and streamlined flows and turbulent flows and a variety of equipment and aircrafts and even racing cars. All of these aerodynamics of the vehicles can also be analyzed in this one. Now, each of this subject, CAD/CAM or FEM or aerodynamics, they are not taught by any simple person with a PhD. These are actually taught by experts around the world. So what I'm gonna do, I'm gonna actually ask one of our experts, Dr. Aarti, who just presented initially. She is actually expert in CAD/CAM, and she actually teaches this subject to a global pool of students and lecturers. She even trains lecturers and people working in the industry. So I would like to invite Dr. Aarti briefly to show what she teaches in her classes. So welcome, Dr. Aarti.
Thank you, Milind. What I'm going to do, I'm going to share my screen. And I will just try to give you a sneak peek into what our bachelor's first semester students start with. So you start your bachelor's journey with one of those really nice, interesting, and I would say slightly challenging unit. So students usually learn how to prepare this sort of parts. They prepare or create the parts. They put them together into this sort of assembly. And they also prepare some really nice presentations using the parts that they have created. So it's really great to see the students starting from scratch. A lot of them are fresh from the high school and still learning through the journey, and towards the end of the journey, feeling quite confident and just working with those drawings. Now, working drawings, they are inevitable part of any engineer who is working in industry. So we have a lot more focus on what actually industry needs. But that was just a sneak peek for what the students start with. And this is the second part where they would actually do some more in-depth analysis. Say, for example, if you want to see some sort of velocity, so we can quickly select components and we can just give it a go. And it will create the velocity plot. So this is what our master student do in terms of CAD/CAM. This is just a part of it. It's not everything that they do. I'm just trying to give you a bit more sneak peek. But yeah, that's from my end in terms of CAD/CAM. That's what if you join bachelor's or master's, you will be learning.
Thank you very much, Dr. Aarti. It was a very good insight into the CAD/CAM softwares like Autodesk Inventor and sorry, not Autodesk Inventor, but Autodesk Inventor and SolidWorks. So that's a beautiful simulation which you have showed us. And getting back into the slides, just give me a few seconds. I'm to reload the slides. Won't take more than a few seconds. So yeah, that's what we do in mechanical engineering. We solve everyone's problem, whether you are working in mines or wanting to work in mines or marine or space science, aeronauticals, vehicle design, automobiles, anything you name an industry. Even construction industries are requiring lots of mechanical engineers. Energy engineering also requires lots of mechanical engineers, and you are trained to be proficient mechanical engineers, and our goal is that you are really industry ready. When you finish your course, you'll be so empowered because you learned all this industry software and you did a really good practice with them, and you would be very confident presenting those projects which you completed in your CV and in your interviews, and you can get the job and hit the ground running. And that's what I truly believe you would achieve. So with that, guys, this here is the slide for some feedback, and I think that's all for today. So please scan with your mobile phone this QR code, and you will have an opportunity to even enter the prize draw for Virtual Open Week 2023. And if you fill your details, and there will be 2 winners announced at the end of probably in the next week. And so please scan it and give some feedback. And yeah, so I'm just trying to see what questions we have.
Thank you, Dr. Milind. I was able to answer some of the questions here. And yep, you can also provide your own answer as well or to add to them. And one here says, what is an expected 10-hour per week workload for a 2-year full-time master's degree? Do you have any recommendations when it comes to that?
So some of the questions I see is completing a graduate certificate or graduate diploma. Yes, that's always an option, but meeting the admissions criteria is what you have to look for. Did I miss anything? Otherwise, Dr. Aarti can jump in.
Yeah, I would just like to answer the question that Steve has asked. The expected 10 hours per week workload for a 2-year full-time master's degree. So pretty much that would be the case, Steve. And 10 hours per week is recommended for per unit. So if you are taking 2 units per semester or per term, then it can go to 20 hours. But out of 20 hours, the 2 main hours, they go into your tutorial and you're listening to the pre-recording, and then other 8 hours, that's the recommended study time, and you need to do some assessment work, research, etc. So yeah, that's recommended.
So I can see some more questions like Pasi has asked, I have a degree in mechanical from UK. What professional certificate could you advise? Probably, yeah, Lisa could probably help you with that. But depending on what degree you have, Pasi, from UK. based on that, we have to review your documents. And Steve asked, are you able to do a master's in a part-time mode, Master of Mechanical? Definitely, Steve. It's very flexible. Kind of, it's divided into term system. So you could do 4 terms in a year, and you'd be doing only 2 units or 2 subjects at a time. And it's quite popular. Master of Engineering and Mechanical is quite popular with industry people, even senior engineers and some of the managers who only hold bachelor's degree. They have pursued and they are pursuing masters in mechanical engineering online, or sometimes they join on campus as well. Yeah. I can see most of the other questions Lisa has kindly already answered, so I'm not looking into them. But let me know if you have any more questions.
Yeah, I would like to answer Ellie's question as well. Maybe you have the best insight for this, Dr. Malin. So Ellie would like to know what is recommended per week for a part-time degree, and we would say like half of the units for us, course advisors. We would most likely say half of the number of units in a given semester would be the best approach to a part-time degree. But again, it would be case by case depending on the workload that they have as well for their jobs. So, do you have any other recommendations for this one?
Yeah, mainly, it depends, as you say, it depends on how many units or subjects would you take in a term or a semester. So if you take 10 hours per unit, that's what we recommend. So if you just take 1 unit, it would be 10 hours per week. If you take 2 units or 2 subjects, it would be 20 hours per that week. So based on your availability and your other commitments, in the part-time mode, you can choose how much load or how many hours you want to take. So if you're really busy, you can take just 1 unit or maybe 2 units.
All right, thank you.
Can see Francis asking, can I do BSc in mechanical engineering? For how long I am in Liberia? So Francis, Bachelor of Science in Mechanical is 3-year course. And if you wanna do it part-time, obviously it will be longer, but full-time it would take 3 years and 6 semesters. And there are possibility of online and on campus, both of them. And Benjamin is asking, after completing advanced diploma in mechanical, what's the next recommended course to enroll in? It depends, Benjamin. So the immediate next step would be a Bachelor of Science in Mechanical Engineering. That's what you should be looking for. Yeah. And Samuel asking, thank you for presentation. And Ukanwa asking, what about graduate certificate in mechanical engineering? So for graduate certificate, you can do, because it's just 1 semester or 6 months long. And even some of the students who complete advanced diploma and they have significant experience, they can jump straight from advanced diploma and few years experience and go straight into graduate certificate in mechanical engineering. Some students have done it, but yeah, otherwise you can, it depends on what your background is, Ukanwa. All right, guys, I can see very good questions and excitement in the students. Looking forward to join mechanical engineering courses with EIT, and I would love to welcome you, really.
All right.
Yeah.
Thank you so much, Dr. Miland, and thank you so much, everyone, for attending um, this session. And again, please don't forget to register or to do the survey for your price draw. You can scan this QR code. I also sent the link in the chat. So please go ahead and use that link as well if you find the QR code quite tricky for you. And also for those who have very specific questions and you are interested in discussing that one-on-one with a course advisor, please go ahead and book a call with a course advisor using the link that I'll be sending now in the email. I mean, sorry, not in the email, but in the chat box. So this is a really great opportunity for you to discuss about your qualifications, what will be the next step when you finish a certain course and so on, and about your eligibility for a certain course as well, or other options that you can choose from our courses if you can't be eligible for a certain course. So please go ahead and book a call with a course advisor, and yep, we can discuss that from there. And yep, we can also have a look at your qualifications, whether it's a national diploma, a bachelor's, or a senior high school qualification. We can recommend certain courses for you. You can choose your own date and time, and the course advisor will call you in that particular date and time. And for those who have further questions and don't want to book a call, you can send an email to webinars@eit.edu.au. Even if you have questions for our lecturers in here, we can forward those questions to them if you send them to our webinars@eit.edu.au email address. All right. I know that you have a lot of questions still, but we have already used up our time for this session. And feel free to visit our website. That's www.eit.edu.au to know more about the school, and extend it to /schedule for you to also see our list of courses that are upcoming and our upcoming intakes as well. So I will just put it in here as well so you can have a look at our list of courses. And for those who'd like to visit us, we are at 1031 Wellington Street in West Perth. That's our head office. For those who'd like to call us, we have our phone numbers in here for those who are calling from inside or outside of Australia. And that's it. Thank you so much, everyone, for attending this session. And we would like to thank as well Dr. Milind, Dr. Arti, and Dr. RV as well, or Aravan, for their contributions for this particular session. And those are really great information that we have learned today about mechanical engineering, and they've shown a lot of examples that would give us a glimpse of what the industry is like. And I hope that everyone had learned from that. So thank you so much. This will be our last session for the virtual open week, and we hope to see you next year in our virtual open week if still do this. And we also have upcoming technical webinars. Just visit our events page. And that's it. Do you have any last or final messages, Dr. Milind, Dr. Arti, before we go?
Yes, definitely, Lisa. I'm really thankful to you for coordinating and organizing this event for mechanical engineering for us. It was a pleasure having you here.
Thank you very much, Lisa. And thank you, everyone.
Thank you so much, too. And thank you, everyone. Have a great evening or morning or noon. Bye for now.